Before we begin Chapter 5 in your textbooks, I'd like to complete a factoring review with you. This is a very important skill, not only in Algebra 2, but when you continue on to college courses or pre-calculus next year. When you factor, you should always check for a greatest common factor first. Okay? When you identify a greatest common factor, remember you can pull out constants, so those are numbers, and also variables. When you're pulling out a variable, though, you need to make sure that you only pull out the lowest power. For example, if I have 3a squared minus 9a, to identify the greatest common factor, I'm going to look at the constants first. So I have a 3 and a 9. Both of these numbers are divisible by 3. So I'm going to pull out that 3. Both terms also have the variable a. I have an a squared and an a to the first power. So that lowest power would be a to the first power, meaning the GCF is 3a. Now, that's not it. Technically, I haven't factored anything yet. I've just identified what the GCF is. So in order to factor, you're going to pull out that GCF, so 3a, and put it in front of a set of parentheses. Inside of the parentheses, we're going to write what remains. And what I mean by that is, what will we have left after dividing each term by the GCF? So we're dividing each term by 3a. 3 divided by 3 is 1. A squared over a. Remember your properties of exponents. You could subtract those powers. So 2 minus 1 is 1. So I just have a to the first power. I'm going to keep that negative sign. 9 over 3 is 3, and then the a's would cancel out. You always want to check and see if you can factor any further. So is there any way I could factor a minus 3? No. When we factor using a GCF, which we've already done, or we factor quadratics. Next, we have factoring trinomials. Remember, trinomial just means something that has 3 terms. And there's actually 2 different cases we're going to take a look at. There's case 1, which is when a is equal to 1, where a is the leading coefficient. And then also, we're going to take a look at case 2. Case 2 is when a does not equal 1. I'm going to star case 2 because that is what I've seen the most mistakes in. Okay, we really need some extra practice with case 2, and you'll notice on your homework we have more of these types of problems. Let's go back to case 1. So with my class, what I've done before is I used what is called guess and check. Some students also chose to use box method, which is something else that I've taught. And if you had a different teacher, you may have been taught another method, and that's okay. We're going to end up with the same answer. Remember, you should always check and see if there's a GCF that we can pull out first. In the first example, I have x squared minus 5x plus 6. So that does not have a GCF other than one that I can pull out. When a is equal to 1, it's pretty simple. All we have to do is ask ourselves, what factors of the last term will add to give me the middle term? The factors of 6 are 1 and 6, 2 and 3. Now, because this is a positive 6, which is what the hints relate to up here, Because it's a positive or addition, I know that I'm going to have to use same signs. So I'm either going to have to use a plus plus or a minus minus to get a negative 5. If I look at the 1 and 6, there is a way I could get negative 5, but not using same signs. So I cannot use the 1 and the 6. Which means I would have to use a negative 2 and a negative 3 in order to get my negative 5. That being said, I'm now ready to write my final answer. The factors of x squared are just x and x, and the factors of 6 we wanted to use were minus 2 and minus 3. So this is my final answer in factored form. Let's do it again. X squared plus 5x minus 36. Remember, you should always check for a GCF first. And in this example, there is no GCF other than 1, so I'm good to go ahead and get started. You need to ask yourself what factors of 36 can add to give you the middle term. So the factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now this time it's a negative 36. When it's subtraction, we're going to use different signs, so either a plus minus or a minus plus. Using different signs, I would like to get to a positive 5. So looking at my factors, if I want a positive 5, I would have to have a positive 9 and a negative 4. Notice how signs do matter. It makes a difference if you were to put a positive 4 and negative 4. We're ready to write our final factored form then. The factors of the x squared were just x and x. The factors of negative 36 we said we would use to get a positive 5 would be a negative 4 and a positive 9. That's our final answer. If you factored it another way, ended up with x plus 9 and x minus 4, that's the same thing, you just had it flipped around, so no big deal. All right, case 2. This is the case that we struggle with the most. So with my students in semester 1, I always had them use box method. Box method always works, okay? However, some students really struggle to use that. So I'll post some extra videos from what I use in semester 1 if you need a little refresher and would like to continue to use the box method. Otherwise, I'm going to use a different method. This is a method that one of the other teachers used. And it uses factoring by grouping, which we have to review anyways. So I thought this would be a nice opportunity, and it's actually pretty similar to what we did with case 1. So let's see how it goes, and hopefully it would give you some more clarification. So I wrote the 4 steps we're going to use for case 2. The first thing is to look for a GCF. Remember, we're always doing that first. So I'm going to follow these steps while looking at this example. 6x squared plus 5x minus 4. Sorry, I had a little typo there. Okay, so when I'm looking at 6x squared plus 5x minus 4, there is no GCF. They don't all 3 have the variable x because of this last term, so I can't pull that out. And 6, 5, and 4 are not divisible by anything other than 1. So we're just going to say, okay, there's no GCF. Step 2, find the perfect pair. So this is very similar to what we were doing in case 1. Remember, we always asked ourselves what multiplies to give us the last term to add to give us the middle term. Now we're going to say what multiplies to give us the first and last term to give us the middle term. Okay? So the first and last term being multiplied together is negative 24. So I'm going to look at the factors of a negative 24. It is important that that's negative because remember, if it's negative, that means we're going to be using different signs. Scooch this over so you can see it a bit more clearly. If I were to list out the factors of 24, that would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. Once again, I got the negative 24 by multiplying my first and third term together. I now need to ask myself, using different signs, how would I get the middle term, which is a positive 5? Well, looking at my possibilities here, I would say I need a positive 8 and a negative 3 to give me that positive 5. So now we're going to plug in a negative 3 and a positive 8. Because this was an x squared, the factors of x squared are x and x. Remember, we're asking ourselves what adds to give us the middle term, and it's a positive 5x. So that's a little reminder to yourself. Okay. Step 3 was to write it with 4 terms, which is what we just did. And now we're going to factor by grouping. Remember, factoring by grouping, what we do is we pair the first two together and the last two together and try to pull out a GCF. I do want to mention, when I wrote these 4 terms, I purposely put the negative 3 here with the 6 because I know I can pull something out. And I put the 8x with the negative 4 because I knew that I could pull something out. If you were to have had the 8x here and the negative 3x here, you wouldn't be able to pull out a GCF. So that's your indicator that you would have had to switch the two. Okay, so looking at my first 2 terms, the GCF here would be a 3x. So if I pull out a 3x, what would remain is x minus 1. Looking at my last 2 terms, if I were to pull out a GCF, that would just be a 4. So I would put plus 4 times what remains, x minus 1. I put a plus 4 here because I pulled out a positive 4. Remember, sometimes we could pull out a negative, and you're going to see that a little bit later in your homework. All right, factoring by grouping. Remember, we want the same thing in these parentheses, which we do have here. So I can pull out that now GCF of x minus 1, and then in parentheses, I'm going to write what remains, 3x plus 4. Always check and see if you could factor any further. I cannot. So this is my final answer.